All right, so let's solve some logarithmic equations. In order to solve a logarithmic equation, you want to make sure that you have log equal to log with the exact same base. So with that being said, look at the directions at the top. Step 1, you have to condense each logarithm. That means get rid of any multiple logs that are in the problem by condensing it to multiplication and division. And then you want to use what's called the one-to-one property. That tells you if you have log base b of m equal to log base b of n, that means you have the log of the same base. And notice there's 1 on each side, and that's it. So if this occurs, you can set m equal to n, and you can solve from there. After you've finished and you get a solution for your x, y, z, whatever's in the problem, you need to put it back into the logarithm and check it and make sure that it doesn't have an extraneous solution. Because sometimes on these you can solve an equation and get an answer for the equation, but when you plug it in, it will not give you a solution for your logarithm. So looking at number 1, you've got log base 5 of 5x plus 9 equals log base 5 of 6x. You'll see that you have log base 5 equal to log base 5. So with that being said, what you can do is simply drop the log base 5 and set 5x plus 9 equal to 6x, and then solve this equation for x. So we get the proposed solution of x equals 9. So what I'll do is I'll go to my calculator, and where it says log base 5, remember to use MAM. That's math, alpha, and math, and that'll give you the log of any base. So what we have here is log base 5 of 5x plus 9. So base 5 of 5x, well, we solved and found x to be 9 plus 9. Okay, and then hit the enter key and you get a solution. So that means that x equals 9 is a good answer and it's not extraneous. If we do math, alpha, math again, log base 5. Now this one is 6x. So that will be 6 times our solution of 9. And you see you get the exact same thing. So by plugging in and checking x equals 9, we see that we get the correct answer and it's not extraneous. Number 2, you're in the same situation, so you can set these, you can drop the log base 2, and you can do 1 minus 4n equals 2n plus 43. Let's solve by moving 4n to the other side. We're going to add, because that'll cancel out, leaving us with our 1. 2 plus 4 is 6n. Now let's subtract 43 from both sides to get negative 42 equals 6n. Divide both sides by 6 to get n equals negative 7. Okay, now if you check it, math, alpha, math, and so we have log base 2 of 1 minus 4 times n, which is negative 7. Okay. Now going to the other side, math, alpha, math, log base 2 of 2 times n, which is negative 7, plus 43. The exact same thing on both sides. Okay, so these are the ways that you check for extraneous solutions. Just always plug them back in, and you're basically looking for a number that's a non-negative. When you plug it in and simplify it, this should be positive, and you won't get an extraneous. Okay, so looking at a problem like number 3, you've got log base 9 of 6 minus 3w equals log base 9 of negative 2w. So because we have log of 9, I can drop that and solve the equation. Now let's add 3w to both sides, and that'll give me 6 equals w. But when I go to plug it in, I have math, alpha, math, log base 9 of 6 minus 3 times w, which is 6. And it says I have an error, a non-real answer. So what that means is when you plug it in, you're actually getting log base 9 of a negative number. Therefore, it won't compute. And if you go to the other side, you'll get the exact same thing. You've got log base 9 of negative 2 times 6. Negative 2 times 6. Okay, and you get another error message. All right, so let's move on. Since this is extraneous, you can just mark through it and you can just have no solution for that one. Okay, so next, if you look at number 4, you'll see that you have 2 logs on the left side. You can only have 1, so we're going to condense this into 1 logarithm. Remember, if you have addition and you have the same log, you can condense it into multiplication. So pull the log to the front, and we're going to multiply y plus 5 times 4. But I'm going to put the 4 in the front. And that's going to equal the log of 72. Remember, when you have the log, that's your common log, so it's actually log base 10. It's just understood to be there. Okay, so since we have log equal to log now, we can drop the log and we can solve this equation. Let's go ahead and get rid of that 4 by dividing both sides by 4. 4 divided by 4 is 1, leaving us with y plus 5. And over here, we're going to get 72 divided by 4, which is 18. And now we'll subtract 5 from both sides to get y equals 13. Okay, the only place we can plug this in is right here. So since this is the natural log, or the common log, I'm sorry, not natural log, the common log, we can use the log button beside the 7. So the log of y, which is 13 plus 5, and you see you get a solution. So all is well. On a problem like number 5, where you have the big number in the front, go ahead and move it to its exponent form using your power rule, and you'll have log base 7 of 4 to the 3rd power equals log base 7 of 4a minus 8. Since you have log equals log, go ahead and drop them. And we have 4 to the 3rd equals 4a minus 8. 4 to the 3rd power is 4 times 4, which is 16, and then 16 times 4, which is 64. Let's add 8 to both sides, and that'll give us 72 is equal to 4a. And then we'll divide both sides by 4 to get a equals 18. So if we go to the right side and we do math, alpha math, we'll have log base 7 of 4 times a minus 8, and we get a solution. And it should equal the same thing as log base 7 of 4 to the 3rd. And you can see it does, which is also the same thing as 3 times log base 7 of 4. They're all the same solution. I'm sorry. Okay, so if you turn to the back, looking at number 9, you'll see that you have log base 4 equals log base 4. Well, that's exactly what we need. So we can drop the log base 4 and we'll get m squared is equal to 18 minus 7m. So when you're solving a quadratic, which is a degree 2, remember we can use all the methods that we used when we were doing our quadratics before. We can use completing the square, we can use the quadratic formula, we can use factoring, we can use square roots. So looking at this problem, I suspect using this factoring method is going to be our best bet. So we'll have m squared plus 7m. Let's move the 18 over here as well. And so we'll have minus 18 is equal to 0. So when you move everything over with the square, make sure that you put it in standard form, which is ax squared plus bx plus c. Now take your negative 18 and list the factors of 18. 1 times 18 is 18, 2 times 9, and 3 times 6. Now we need opposite signs with the biggest one positive. So let's make all of our little factors negative. So all of these multiply to negative 18, but the ones that add to give us positive 7 are negative 2 and positive 9. So my factored form is m minus 2, m plus 9. Now let's set each of these equal to 0 and solve. So we'll get m equals 2, and we'll get m equals negative 9. Now we need to take both of these and check them for extraneous solutions. So we're going to use log base 4 of m squared. So math, alpha, math, log base 4 of m, let's check 2, and square it. Perfect. Okay, math, alpha, math, so log base 2, and then we have negative 9 squared. Make sure you put that negative in parentheses before you square it in this calculator, okay? And so you see that both of them give you a solution, letting you know that both of these are solutions to the equation. When you do a problem like number 10, you see that you've got 2 logs on the left side. So the first thing I need to do is condense. Pull out your log, and since we have addition, we're going to condense it into multiplication. Okay, so now we have log equals log. That tells me I can drop the log and solve the equation. So let's subtract k squared from both sides. Okay, since we have k squared equals 16, the easiest and best way to solve this is simply to take the square root. So the square root of 16 will be the positive and the negative 4. So if you plug in positive and negative 4 when you square it, you're going to get a positive value both times. So that tells you both are solutions to the logarithm. Now, looking at a problem like number 11, you see that we only have one logarithm, and it's equal to a number. So if this ever occurs, instead of doing log equals log, we have log equals a number. Make sure it's your logarithm all by itself, log base 2 of whatever. There shouldn't be anything added or subtracted or extra with the logarithm. If there is, you're going to have to fix that. And so once you get to this spot, use the log loop to change it into an exponential function. So the base of the log is the base of your power. And then whatever your equation is equal to, that's going to be your exponent. And then when you have log base b of a, whatever a is, that's what it's going to equal. So that's why the log loop works. It tells you what order to go. 2 to the 6th power equals x minus 4. So when you're dealing with 2 to the 6th power, you're dealing with 64 again. So you have 64 is equal to x minus 4. Add 4 to both sides, and you get x equals 68. Now this is also an acceptable solution because you will plug it in and you won't get a negative there. Okay, looking at number 13, you have 2 logs. We need 1, so let's condense. Pull the log to the front. Since you have addition, you're going to have to do multiplication here. Okay, now in order to solve this, since we have a log equal to a number, you're going to use the log loop again. Since this is your common log, we know that the base is 10. So 10 to the 2nd power is equal to all of this. So 10 squared is 100, and then let's multiply here and here. That'll give me 2x squared minus 10x. Go ahead and move your 100 over here so that we can factor. Now when I look at this, I can see that I have a GCF with all 3 terms, which is going to be a 2. So I'm going to pull that out first, and I'm going to go to the side over here because I am quickly running out of room. So I have 2 times x squared minus 5x minus 50. Now, if we divide away the 2, it simply goes away. And so we're going to factor out our negative 50. 1 times 50, 2 times 25, 5 times 10, and then we need opposite signs, biggest one negative. So all of these multiplied to give me my negative 50, but only 5 and negative 10 add to give me my negative 5. So I have x plus 5, x minus 10. So set both of these equal to 0 and subtract and add, and we get 10 and negative 5 as our solutions. But we are, of course, going to check this and make sure that we did everything right. Okay, so now we have the log of 2x, so log of 2 times negative 5, plus the log of x, which is negative 5 minus 5. Error message. So that tells me negative 5 is not a part of the solution set. It's extraneous. So just mark it out. Then if you check 10, you'll have the log, and I'm going to replace negative 5 with 10. And then here I'm going to replace negative 5 with 10. And looky there, that one worked, didn't it? So that means 10 is a part of the solution set.